Hi everybody, tonight's video is going to be about circles, and we'll start with a definition and talk about standard form, and then we'll talk about a few other things including graphing and x and y intercepts and all that good stuff. So to start, we're just going to go with the definition. A circle is a set of points that is a fixed distance away from a fixed point. So the fixed distance is the radius, and we should be familiar with that. And this fixed point is going to be the center of the circle. Okay, so whenever we are talking about circles, we're also thinking about what the radius is and what the center is. And the reason for that is because the standard form of the equation of a circle uses the radius and the center. Just like we've been using with lines, like we've always wanted to have like the slope and y-intercept has always been helpful because once we have those two pieces of information, it's easy to graph. Same thing with a circle. If we have the radius and the center, then it's easy to graph. The circle. So the standard form of the equation of a circle looks like this. It's the quantity x minus h squared plus y minus k quantity squared equals r squared, or the radius squared. So if I have this point hk as my center and r as my radius, I can plug it in to this standard form of the equation of a circle. The only thing that we have to be careful about here, so if we have an example and we say that 4 is the radius, and the points -3, 2 is the center. If I'm going to plug this in, the thing I need to know is that this is x minus h and y minus k. So if I want to put this information into the standard form, I would say this is x minus -3 quantity squared plus y minus 2 quantity squared equals 4 squared. So that's x plus 3 squared plus y minus 2 squared equals 16. So this is x minus h and y minus k. So sometimes it's pretty easy to identify when there's a minus sign in the middle. So that would be k is 2. But here, since h was -3, it's really minus -3. So that's where we got that plus 3 from. So if you're going in the reverse direction and you were to see something like x plus 4 quantity squared plus y plus 3 quantity squared equals 25, from this, when you're going backwards to find the radius and the center, just be careful, because when you see that plus in the middle, that should tell you that h is really -4, and here k is -3 because it's a minus. So if it's a minus, you're actually going to take the opposite there, because that would be minus -4. Okay? And in this case, the radius would be 5. All right, so those are just some pointers about going from standard form, going to standard form, given the radius and the center, or going from standard form to identify the radius and the center. And this is all helpful for when we want to write an equation and graph it. So a radius of 5 and a center at -2, 1. So in this case, h equals -2, k equals 1, and our radius equals 5. So if I set this into standard form, x minus h quantity squared plus y minus k quantity squared. K is 1, so y minus 1 quantity squared equals our radius squared. So 5 squared is 25. And then I would just simplify this as x plus 2 squared plus y minus 1 squared equals 25. Now if I want to graph this circle, I'm going to put a point at my center, which is -2, 1. So to the left 2 and up 1. So we're going to put our point right there. And then our radius is 5 units. So radius is 5. So I can move 5 units in each direction and put a point. 1, 2, 3, 4, 5. So I go 5 to the right and put a point. Go up 5. 1, 2, 3, 4, 5. Go to the left 5. 1, 2, 3, 4, 5. And go down 5. 1, 2, 3, 4, 5. All right, and then we're going to connect those as best we can with curves to make this shape look like a circle. That's probably the easiest way. That's pretty sloppy, but that's probably the easiest way that you'd be able to graph this by hand. I think the feature here, right, you can also see that was kind of close. So you're going to have the center here, and then your radius should extend from the center to any point on your circle, right? That's your fixed point, and this is your fixed distance, and this is the set of all those points that are a fixed distance away from that fixed point. Okay, so that's how you would graph this. You plot the center, then plot points that are the radius distance away from the center, which is easiest when you're moving on straight lines, so either going up, down, left, and right, and then you connect that with a circle as best you can. You can also use your compass if you have one of those. So you'd put the point at the center and the pencil the 5 units away here, and then you would draw your circle like that. So that's how you would graph a circle. Now, we can also find intercepts for a circle just like we did for a line. So very similar, if we want to find the y-intercepts, we're going to let x equal 0. And if we want to find the x-intercepts, we're going to let y equal 0. So if I have, for example, let's take the equation x plus 3 quantity squared plus y minus 2 quantity squared equals 16. And I want to find the intercepts of this circle. We already know what the center and the radius is pretty easily from looking at this. H we know is -3, k is 2, and our radius is 4. Remember, because this is r squared, so we're taking the square root. That's why I know that that radius is 4. So I know the center and I know the radius. Those are 2 important parts. But if I want to find the intercepts, I can just let x equals 0 and solve for y. We're gonna be dealing with square roots here because when we put in x equals 0, it doesn't really cancel out this term like it did when we were working with lines. If I let the x equals 0, the ax, if we were talking about general form of a line, that whole term just disappeared, and all we had to do was divide to figure out what y was. But here, that's not going to happen. So we have 3 squared plus the quantity y minus 2 squared equals 16. So that's 9 plus y minus 2 quantity squared equals 16. Let me move this out of the way. Move this down here. And so now I would subtract 9 from each side. And I would get y minus 2 quantity squared equals 16 minus 9. That's 7. And so now I have this y minus 2 quantity squared. So the way to get rid of the squared is to take the square root of both sides. And when I take the square root, I have to remember there's the positive and negative square root. So I get y minus 2. Y minus 2, the square is gone, equals plus or minus the square root of 7. Last thing I want to do is add 2 to both sides. And so my y-intercepts happen at 2 plus or minus radical 7, right? Because I added 2 to this. I can just leave the radical 7 like that. So there's really 2 intercepts. That's at y equals 2 plus radical 7 and y equals 2 minus radical 7. Okay, so that's how you would find the y-intercepts. You do very similar for the x-intercepts. only you would be plugging in 0 for y and then solving for x. So that's going to be your assignment to bring that to class tomorrow. Find the x-intercepts of this equation. So you're plugging in 0 for y and then solving similar to this. So when we're doing this, we can also graph. We can graph this circle. So here's the circle that we have right here. Same equation, x plus 3 quantity squared plus y minus 2 quantity squared equals 16. Now if we go to our graphing calculator, we can find our intercepts pretty easily here. So you can check your intercepts from these values. So those are the two x-intercepts. You'll get negative 6.464 and 0.464 as your x-intercepts. And here we go for the y-intercepts. I have 4.646 and negative 0.646. So you can pick out the intercepts from doing the graph here. Let's see if we can put in an expression if it'll evaluate what is 2 plus, 2 plus radical 7 is 4.64, right? So we had 2 plus radical 7 and we had 2 minus radical 7, and that's negative 0.64. So does that check out with the y-intercepts? Yeah, so there's 2 plus radical 7. Down here is 2 minus radical 7. So those are the two y-intercepts I found. And so now you're going to find the x-intercepts. Okay, so last thing we're going to talk about is, if you'd like to, you can use completing the square to put a circle in something called general form, not to be confused with standard form, right? So standard form is what we've been talking about so far. It's x minus h quantity squared plus y minus k quantity squared equals r squared. General form is a bit longer. It's x squared plus y squared plus ax plus by plus c equals 0. So this is just another form that you can use to graph or write the equation of a circle. Going from standard form to general form is not all that difficult. It's really just a matter of foiling out the squared terms here and then subtracting the r squared over. So if we're going to use our equation that we've just been using, so x plus 3 squared plus y minus 2 squared equals 16. All I would do here is FOIL this out. So it would be x plus 3 times x plus 3, right? Because that's the definition of x plus 3 squared. It's this term times itself. Then I have plus y minus 2 times y minus 2 equals 16. So now I just FOIL this out. So I'm going to get x squared plus 3x plus another 3x is plus 6x. Plus 3 times plus 3 is plus 9. Okay, so I got that all simplified. Now y times y is y squared minus 2y minus another 2y is minus 4y. And negative 2 times negative 2 is plus 4. And that all equals 16. And let's continue to simplify, right? So I need to get the x squareds, y squareds, and ax, by, and c. So let's say we're going to have x squared, then move this y squared over to here. Then I have 6x. Then I want by, which is negative 4y. And now I have all of these whole numbers to combine. So now I have plus 9 plus 4 minus 16 equals 0, right? I'm going to move that 16 over. So my last step to get this into what is called general form is to just simplify the whole number. So I have x squared plus y squared plus ax, which is 6x, plus by, which is negative 4y, and then 9 plus 4 minus 16 is going to give me negative 3. Right, so 9 plus 4 is 13, 13 minus 16 is negative 3. And so that's your C from the general form, and set that equal to 0. So going from standard form to general form isn't that bad. Just FOIL this out and simplify everything so that it's in this form. Move over everything so that you have it equal to 0. Going from general to standard form is a little bit more involved. It would involve completing the square. So if you're interested in doing that as a little bit of a challenge, check out example number 4 in your textbook, which is on page 47. So I will invite you to check that out on your own. You might see this as a bonus question on a test or something like that. So it'll just need a refresher on the process of completing the square, and I will leave that up to you. So bring these notes to class tomorrow. I will see you then. Let me know if you have any questions. You can feel free to email me tonight if you have any questions on the video or anything like that. Otherwise, I will see you in class. Have a great night.